Agwineus Akorja, and my name is Paul Cunningham. Welcome back of IST-Africa 2022. We now have a very interesting presentation by Carla on long-term potential and sustainability of space science and technology.
Hi, I'll be speaking on long-term potential and sustainability of space science and technology, particularly in Africa and with respect to space science like radio astronomy. Space sciences generally have infrastructure on the ground looking up to space to answer our burning questions about the universe. Some infrastructure is based in space, such as the newly launched James Webb Telescope, but mostly it's on the ground looking up. In contrast, the space industry has its infrastructure in space, looking back at Earth, and it's big business. Satellites are used for communications and Earth observation. An example below is disaster management. One can see the effects of a cyclone in Mozambique. On the ground, one can't see what's going on. But with satellite data, we're able to see access points, damaged areas, and provide relief. In Africa, we often ask, why science, why technology, in the face of the many challenges we have on our continent? But space science and technology contribute to all 17 of the Sustainable Development Goals. It's a sector not to be ignored and should be embraced. I work for the South African Radio Astronomy Observatory, and we're implementing South Africa's commitments towards a square kilometer array. The SKA will be an engineering and technology feat. It'll be the largest telescope on Earth. It's certainly the largest technology project in Africa. The low frequency part of the telescope will be built in Australia, and the mid-frequency part of the telescope will be built in South Africa. As a precursor contribution to the project, we built the Meerkat telescope. And once SKA phase 1 is complete, the Meerkat will be integrated. In studying mega projects and their successes and failures, and in looking at SORAO's history over the last 20 years as a case study, planning is key to success. And this may seem intuitive, but it's not just planning for infrastructure implementation. It's a holistic planning over a number of areas. And I'll touch on these as I go through the presentation. Firstly, we look at policy, institutional structure, and institutional support. For Meerkat, we've had a number of strategies, white papers that support this project produced by the Department of Science and Innovation. The Meerkat site itself is a national key point of South Africa, and Meerkat and the SKA form a special infrastructure project of our national government. There are acts in place, such as the Astronomy Geographic Advantage Act, which protects our site from interference. We also have a robust, publicly funded Intellectual Property Act, which has enabled us to successfully partner with industry, spin out innovations, and if need be, even open source technologies. We built the CAT-7 telescope, 7 dishes, as an engineering prototype. This was to test technologies and prepare for the Meerkat telescope. It did very good science until it was superseded by Meerkat, and it is now redundant. We're looking at a number of options to potentially bring it back to life. One such option could be the business case around satellite and space debris tracking. Planning, again, as we touch on this, an important area is to acknowledge capacity and to develop capacity appropriately. As I mentioned, CAT-7 tested the technologies and capacity for the Meerkat telescope, but it also was built to demonstrate South Africa's ability to host the SKA. The Meerkat was completed in 2018, and it's made up of 64 radio astronomy antennas. Each stands 5 stories high. This was the first image produced by our telescope. It's the center of our Milky Way galaxy. The bright area in the middle shows our black hole at the center of our galaxy. To the left of that bright area is another smaller bright area, which is a star nursery. This is where stars are continually being formed. And to the left of that area, those bubble-like features are actually supernova remnants, what I term a star graveyard. So important to radio astronomy is that it's essentially a data science. It involves a lot of data, and the technologies that are required for huge amounts of data to be stored, transported, and analyzed. For Meerkat, we were resource constrained, And for the supercomputer at the back end, we were required to design and have manufactured our own supercomputer. It is now the most efficient of its kind in Africa, and we did it for 30% of the cost of other solutions. Because of constraints and necessity, a number of innovations were developed during this project. The data link from Meerkat to site is about 100 gigabits per second, and with SKA, this will be required to increase to tens of terabits per second. The dishes generate the equivalent of 5,500 digital TV stations at the same time. This is about 2 terabits per second. In the back-end computing, during correlation, this can be phased up to as much as 15 terabits per second. Meerkat is also unique in that it's a multicast instrument. This allows it to do more than one science at a time, which is wonderful for collaboration and developing partnerships. I mentioned the importance of radio astronomy being a data project because in Africa, we have a terrible lag in digital skills, as one can see from the chart here. In developing the skills towards our project, we've given a number of bursaries, we host hackathons, workshops, and we work hard not only in South Africa, but in our partner countries in Africa to develop digital skills towards the future. I actually just visited one of these workshops, and the wonderful results that were being produced by students, results for people on the ground, very real solutions for everyday people using advanced digital skills. These are the young people that are going to change the face of Africa in the future. Oh, sorry. So the South African Radio Astronomy Observatory has awarded over 1,500 bursaries over the last decade. We did this to develop a pipeline of skills necessary for the project. By starting this years before we even started construction, we were able to develop the skills that could participate in design, construction, and operations, maintenance, and science. We also have programs with partners like DARA in Africa, and in our partner countries, we're running radio astronomy schools, big data schools, and 130 of our bursaries were awarded to partner countries. So in the planning discussion, human capital development is essential. Developing that pipeline of people that are going to be able to utilize your infrastructure. No country wants big science instruments that their own citizens can't do science on. The HCD program includes many activities, all the way from school level to artisan training, up to PhD and research chairs. In my personal research, the science-driven economy is what I'm developing, and this comes largely out of my case studies. These projects need to begin early with outreach, public outreach, awareness, and basic education from a school's level. We call this an intervention phase and the early development of a human capital program. Moving from this into the development phase, where we begin with the development of infrastructure and facilitated development for industry. We as a project developed industry to participate in Meerkat, and we ran financial assistance programs to help capacity building in companies so that they can competitively bid for contracts in the SKA phase of construction. We looked a lot to localization and even assisted some small companies to be able to move from importing to their own manufacture and export. Out of all of these activities comes innovation, and this innovation is passed through our commercialization process. But this is a cycle, and an ever-increasing cycle. It strengthens and grows, and has done over a decade before the completion of Meerkat. We benefit from projects like Meerkat, not just in the great science, but in many other socioeconomic areas. And this is the reason governments do these projects, to grow national benefits. We did this as public goods, whether we were building roads, we implemented over 110 kilometers of power lines, upgraded substations in the area. We've impacted cultural effects. We have a partnership with the Sand Council. We've run astronomy art projects. We have ICT and industrial spillovers that I've mentioned. Of course, foreign direct investment will pour in through the SKA project. I've mentioned education and training, and then of course science products. The science products are worth noting. Our pipeline has produced about 170 PhDs and 260 master's degrees in science and engineering. Our high impact science and skills development attract international investment and science projects. We host a number of very important guest instruments on our site doing partnership science. We also participated in the production of the data cube technologies so that our National Space Agency can deliver data products. Also worth noting is that in the face of the pandemic, the South African Radio Astronomy Observatory was tasked with managing the National Ventilator Project. In a period of 4 months, our resources designed and managed the manufacture of 20,000 non-invasive low-cost ventilators. This shows the translatability of skills in the astronomy sector. As I mentioned, innovation. I won't go through all the innovation products, but I'm happy to share more information with you. One of my favorites is Ironhive. This is a rugged, low-cost, high-performance computing solution. Essentially, it's a high-performance computer hermetically sealed in mineral oil. This saves a huge amount on cooling and the infrastructure required for cooling. So this makes it a low-cost, high-performance computer, almost a rural data center that can be used for outlying astronomy telescopes, but also for rural communities. So part of our planning discussion is industry development. This leads to innovation. 80% of Meerkat was procured in South Africa. And as I mentioned before, the financial assistance program was a cleverly designed program to cost share and risk share with companies and enable them to further develop their technologies and their capabilities to competitively bid for SKA Phase 1 contracts. I manage the Africa program. So the Africa program incorporates a large portfolio of activities, some South African activities and some in partnership and collaboration, as I mentioned earlier, DARA. These take care of training, workshops in a number of areas, from data, radio astronomy, managing and operating dishes, etc. The bursary programs, internships, graduate programs, etc. Most importantly, the driver behind this is the African Vlbi network. This is a network to implement Vlbi infrastructure across our 8 partner countries in Africa. Vlbi stands for Very Long Baseline Interferometry. Yes, I practiced that. In my limited understanding, essentially, the longer the baseline or distances between dishes, the better your resolution in space. So our first site we developed was in Ghana, as this created the longest baseline out of all the partner countries. This dish was completed. It was a refurbished telecoms dish in 2017. And the second engineering phase is underway now. It was delayed due to the pandemic. But that dish is doing radio astronomy, and a number of workshops and training programs are run at the site in Ghana. One of the big challenges we have in our African partnerships are the operations and maintenance of these sites. There's a lot of cost and resourcing required, and this can be a challenge. In answer to this, we've developed the co-location program. This program looks to co-locate satellite receiving ground stations. As I mentioned, the satellite industry is big business. So having stations across Africa that can receive data for satellites has 2 benefits. One, if you're in partnership with a dish and you can access the data, this data can be used, like I showed earlier, as Earth observation data to help solve national problems, whether it's agriculture, environmental management, water management, etc. Co-located with this is data processing infrastructure, which is utilized by both the radio astronomy dish and the satellite ground station. The same skills are required to operate and maintain both dishes. So late last year, we completed a pilot program whereby industry implemented a station at the Ghana site, and this is working well. The training and resources provided by the ground station are sustaining the site. So that site now does radio astronomy, various data processing, as well as receiving of satellite data. We hope to replicate this in all our partner countries and create a network, each being a hub of science, industry, innovation, and hopefully the development of value-added services in data technology. So that brings to a close all the topics I wanted to touch on. Just to mention, of course, that the last area of planning is partnership development. As I've discussed, co-location, innovation, and intergovernmental partnerships are required to make projects of this size work. And what we've seen in Ghana with the co-location and this hub that is working so well, it's working well because of a partnership between government, academia, and industry, leveraging off the strengths of all three. I hope that you found that useful and interesting. I moved through a lot of topics quickly, so I'd be happy to answer questions and provide more information if you need it. Thank you.
Thanks, Carla. That was very interesting. I have a couple of questions, and if anybody has any other questions or comments, please put them in the chat and I'll call on you. So let's start with some of the more fundamental challenges. How do you manage the expectations of so many potential different stakeholder groups with a project as ambitious as the SKA, while at the same time encouraging creative, imaginative potential applications to be explored by this shared digital infrastructure for the continent?
Hi, thank you for your question. That's a loaded question.
I do my best. I'm sure you will too.
So I think just with reference to expectation management, that would depend on whether referencing the SKA project or the Africa project, because those have different stakeholders for different reasons. I think very specific agreements on what we're trying to do, what the objectives are, having that clarified at the beginning and who is responsible for what is very important. Contributions also matter. In Africa, the large portion of the contribution is coming from South Africa to their program. So expectations, I mean, obviously we have to manage those within timeframes and, you know, what's being given, but the giving is coming from our side. In the SKA project, you have a number of countries all contributing their share and wanting, obviously, to maximize the benefit from it. So expectations are much more complex and it's a much more rigorous process of negotiation. So I think potentially contribution is the biggest challenge to managing expectations because of obviously every country hoping to maximize their benefit from the program. I think, does that touch on?
No, I think it does. And I mean, no. And I mean, that was the reason why I specified the SKA rather than talking about the Africa project, which is, as you say, an easier onion to peel. But, you know, what you said is important. Clear roles, clear contributions, clear responsibilities, and then you negotiate after that. Then as a follow-up to that, and in the same frame, many African countries now have space-related ambitions and capacity, but may hesitate making short to medium term investments, considering that they may quickly become redundant, whether it's due to Meerkat, SKA, continued technological innovation. And in that context, perhaps you could briefly explore the repurposing concept, which I found very interesting, that you mentioned in relation to Cat7, as I think it may have wider implications across the African continent and may indeed open up further opportunities for cross-continental collaboration.
Yeah, absolutely. I think a challenge we sometimes have in Africa is chasing technology for the sake of technology. You know, we talk about technology as a driver for economic growth, but technology is just a tool. It shouldn't be something we chase to say we have it, but deciding on the tools that are best placed to answer our national challenges. And of course, like I mentioned, space is very important to that, and the space sciences. But one thing I think we don't do enough in Africa is collaborate and create African value chains. And I think to have ongoing successful programs within African countries, we need to be collaborating and each forming part of larger programs. We can't do it alone. Nobody in Africa, I think, can do it alone, which is why we have these projects starting, as you mentioned, and then falling apart later. So I think key is collaboration, and we do have capabilities, different capabilities in each country and different infrastructure like Cat7 that can be repurposed. So I think the way to succeed moving forward is definitely creating our own African value chains. And I hate to say it, but simply, and forgive me for not better terminology, but maybe looking a little less at the global situation and rather looking at how African countries can service one another and create these internal value chains, as opposed to trying to compete in a larger space that is very difficult to compete in.
Yeah, because you made the point yourself that one of the achievements, as you perceive it, was that 80% of what went into the infrastructure in South Africa came from within the country. And obviously that's important in terms of building capacity. So I like the idea, and it's very much within the framework of the IST-Africa concept, to have member states across the continent support one another, playing to their strengths and looking for opportunities where you can come up with a 60-70% solution, and then you look elsewhere for what you need, and therefore you're providing opportunities for a wider base. Narcisse from Cameroon has a comment she'd like to share with you.
Thank you very much for the presentation. I found all the materials very interesting, and particularly this presentation. I'm Narcisse from Cameroon, from the University of Chang, and I highly appreciate the presentation of Madam Shara. I apologize if I don't pronounce very well her name. And my question is, I have indeed 3 questions. The first question is, according to you, what can Africa do to increase its presence in the sky? That is, in terms of space technology. And secondly, do you believe that African Union as an entity can succeed in developing a serious space program, as we can see in European Space Agency? If yes, according to you, what is the main problem that they are facing actually, so that they cannot develop, so that we cannot have a proven result? And finally, I would like to know, what do you think can be done in order to improve the rate of internet usage in Africa? Because actually the highest rate belongs to Europe and the lowest rate belongs to Africa. Thank you very much for your clarification.
Hi, thank you for your questions and your appreciation. So to increase our presence in the sky or space technology, like I say, I think there are a number of levels we can participate within the space industry. We don't all need to own rockets or satellites. I think the first thing that's most important to Africa is to be able to start utilizing space data to solve national problems. This is, as I mentioned, whether it's agriculture, resource management, etc. Becoming comfortable with using this data, and then looking towards, building the skills to be able to assess this data, and then moving to the step of perhaps owning infrastructure, collaborating in owning our own satellites, etc. But, there's no need to duplicate in expenditure and effort within and outside of Africa. If we can find ways to be able to access and utilize space infrastructure cost effectively, even if it's not our own, as long as we're maximizing the benefit. in my opinion, that's how we should address it. But yes, there's many ways we can access it further. Is it possible for the African Union to succeed in developing a serious space program? They put a lot of effort into a very stringent policy, which I think was a very good start. Their policy is excellent. In my opinion, from what I understand, I don't believe they have the resources to implement a program across Africa. It is very costly and resource intensive, but there are ways to do it in collaboration with the countries. They can oversee and manage. They have established the African Space Agency, which is based in, I think it's headquartered in Egypt currently. That's fairly new. But the problem with Africa as well, we have different regions. And for example, I mentioned the Vlbi project in Africa, but in Northern Africa, it makes more sense to be geographically part of the European Vlbi than an African Vlbi. So because Africa is large, the geography and the traditional partnerships in that region may dictate slightly fragmented or regional space programs might be ideal. But absolutely, the African Union can see this through, but not without the support and resourcing and partnership of the African countries. And finally, I am not an expert on improving the rate of internet usage. That's a little outside of my area of knowledge, but I think making data facilities available, like we spoke, making data facilities available in rural areas, improving fiber links. But in terms of space, you know, there are a number of satellite chains being launched now that will be providing internet from the sky. And I think the purpose of this is to make internet widely accessible. This is much to the distress of radio astronomers, of course, because of the interference. But I think a lot of international efforts are being made to make internet usage more widely available. I hope that answers your questions.
Yes, thank you very much. I'm satisfied. Thank you.
Thank you very much for the question and for your answer, Carla. And before we finish, I wanted to briefly explore technological innovation on the continent in the context of space. So I love, and the branding is great as well, but I love the Ironhive data center concept. And I can see many potential applications, particularly in the health and agricultural areas beyond space-oriented applications that I would be genuinely interested in exploring with you. But what made it possible to create a fast, efficient supercomputer at 30% of the cost of commercial alternatives? Is there really such a high markup in high performance computing today? Or what types of innovative approaches to the architecture and the components were implemented?
Well, I think the solution came from a combination of clever design and utilizing local manufacture. I think a challenge, of course, price-wise, is if you're in South Africa and you're having to import from Europe or the US, the exchange rate obviously adds a lot of the cost to it. And we were able to use hybrid design, using different components that were required by us and not being forced to maybe, you know, accept an off-the-shelf solution, which perhaps was loaded with cost for a lot of functionality that we didn't require. And then, of course, utilizing items that were on that innovation list, like Scarab, these reconfigurable boards that utilize less power and faster computing. So I think it was a combination of factors. I wouldn't be able to point to one specifically that allowed us to do this. I mean, we have, of course, a lot of great minds and a lot of innovative thinkers within our project, which has definitely helped. And of course, partnering with industry where they see the opportunity to partner with us and help us produce what we require for radio astronomy, because then they are able to spin out these clever solutions or cheaper solutions that we've been able to develop with them.
Thanks very much, Carla. I genuinely enjoyed your presentation, and thank you very much for being with us here today. So that was Carla Sharpe, Africa Program Manager from the South African Radio Astronomy Observatory.
Thank you.